And so it appears that you have clicked on the video that talks about what is an acid. And this is probably something you have heard of lots before. Acid is a very commonly used word that talks about a chemical that is oftentimes synonymous with danger, and no danger is bad. But acids can be very productive and very useful, and we have to have them. As a matter of fact, even there are certain things in our own bodies that require acids. For example, the acid we'll talk about later, HCl, for example. HCl is possible, it makes possible the use of something called an enzyme called pepsin, which is what allows you to digest meat. So you got to have that. So officially, by definition, an acid is any chemical compound that increases the H plus concentration in a solution, which is a whole lot of chemistry talk for if you've got a container of stuff, so let's say it's a liquid, and acids are all contained in water, so we can just assume that there's some, good old-fashioned water in there. And any chemical that increases the concentration of H plus, it makes more of those, then that's considered an acid. And that's pretty much it. There's not a whole lot more to understanding what an acid is than understanding that it makes the hydrogen ion concentration go up. And that's what that is, hydrogen ion. And just as a side note, anytime you see something with a plus, or it could be something like this, where it has SO2 minus 2, or SO4 minus 2. Anytime you see a little minus, that is classified as an ion, or some collection of atoms that have an electrical charge. Okay, that's out of the way. But I really think we ought to spend a little bit more time on what that H plus thing is and where it comes from. This, ladies and gentlemen, is what I talked about earlier. This is hydrochloric acid. And it is... the way you know an acid from any other thing is that an acid has an H in front. All acids do this. And it's kind of a little tip-off to say, hey, I'm an acid chemical formula. Now, there may be other H's in the compound, but if there's an acidic hydrogen, not Hasidic, like Jewish Hasidic, that's totally different, and because otherwise you'd have long hair and have like braids hanging off the side like that. That's a Hasidic proton, not an acidic proton. There's a little chemistry, religious humor there. So anyway, if this is going to be an acidic hydrogen, that means that guy comes off, and when it comes off like this. Oh, man, there was a cool animation. Cool animation, come back. Where does it go? Animation, go. Oh, man, that's cool animation where the hydrogen like pops off and like goes over here. And when the hydrogen comes off, it gave its electron, and we'll talk more about electrons and their role and stuff, but it has this electron, and it gave it to the chlorine, so it no longer has it. It's just a little proton, and it's positively charged, and it's just hanging out there now, and the chlorine right here has the extra electrons, and so it's negatively charged. Now, the negatively charged chlorine isn't going to do anything. It's this thing that does all of the fun stuff. Fun meaning damage or maybe good stuff or whatever, but that's the acidic proton, not anything else. And so now you understand what a basic acid is. It's any hydrogen, and you could, so this unknown thing here could be anything. But what is most important is that H pops off and increases the concentration of H plus. That's basically it. And now that you know, I can get out of here.